Okay, let me open the solution on which we were working yesterday. So this was the solution. So we had developed the dim customer dimension, and we developed the dim date. So we also built a hierarchy. But there are a few things that I would like to add to whatever we discussed yesterday. Um, so we have this calendar year, calendar quarter, so you can rename, because month, number of year and date key does not look nice here, so we can rename this as month, and we can rename this as date. So one more thing that we would discuss is, when you talk about attribute relationships, there is one more thing which is called as, when you talk about attribute relationships, there's something called flexible relationship and rigid relationship. So what is a flexible relationship and what is a rigid relationship is, like, let's say in your attribute relationships, you define the relationship between a parent and a child. So if the relationship between a parent and a child, if it is not likely to change, I'll give you an example. For example, you have your built-in hierarchy where you have country, then you have state, province, and then you have city. So let's say you talk about city, Los Angeles. So Los Angeles will come under a particular state, province, and it will come under United States. Sydney is a city and it will come under Australia. Sydney will never come under United States. So the parent of Sydney, or the parent of Los Angeles, that is kind of fixed. It won't change. So that kind of a relationship where the parent-child relationship is not likely to change, that is a rigid relationship. And if the parent-child relationship is likely to change in a period of time, let's say in a couple of months or so, then it's a flexible relationship. I'll give you an example. Let's say you have built an organization hierarchy where you have different teams, and under different teams you have different employees. So now let's say your team is your parent, and the employees under that who work under that team are the children. So it is like it is possible that you are working in one team today, and so your hierarchy is like that, and maybe after 2 months you are working under another team. So your parent will change. So that kind of relationship is a flexible relationship. So where do you define this rigid and flexible relationship is, you go here in attribute relationships, and by default, the relationships are flexible. Okay, by default they are flexible, but if you want and if you think the relationships are rigid, then you can make them rigid. Usually see the in a date dimension, like a particular month will always fall under a particular quarter. A particular quarter will always fall under a particular year. They won't change. So these relationships are rigid relationships. So you can make them rigid. So how to change it? You go to relationship type and you have flexible and rigid. So you can make it rigid. Okay, so rigid is in dark black and flexible is white. So what is the impact of making this change? As such, there is not much impact of where defining the relationships as flexible or rigid. So even if you leave your rigid relationships as flexible, they will work. But from a performance point of view, what actually happens inside the SSAS engine is, SSAS, people use SSAS to view aggregated data. So when you define a particular relationship as rigid or you define it as flexible, SSAS kind of understands, okay, this relationship is rigid, this is not likely to change, and this is flexible. So SSAS designs the aggregations accordingly. So it is if you define the relationships appropriately, the aggregations which SSAS design, they are more effective and more smarter, because SSAS knows that this relationship will not change, and so it is more information to the SSAS engine for building aggregations. So that is one aspect which it affects. Otherwise, there is not a big impact due to this relationship change. So even if you, while designing aggregations, it helps. And also as a better practice, it is advised that you should define the relationships, the attribute relationships correctly. Okay. Okay. Now, the hierarchy that we build, that's a calendar hierarchy, but you will see in most organizations there is a fiscal year. The fiscal year is kind of a financial year. So which does not start from January and end, because the calendar year usually Like the calendar year, we know it starts from January and it ends in December. But there is a different fiscal year which every organization I've seen, most organizations have a different fiscal year than a calendar year, and they uh, they view all their calculations and everything with respect to the fiscal year. So the fiscal year, it differs from organization to organization. For some organizations, the fiscal year might start from July. From some organizations, it might start from February. For some, it might start from September. So, so it differs from organization to organization, but usually that is how they like to view their data, because all their calculations, all their financial calculations and everything are usually based on the fiscal year, not the calendar year. So here in our date dimension, also we have a fiscal year and a fiscal quarter. So in this particular date dimension, the fiscal year starts from July. So from July till next year June, that is the fiscal year. Okay. So what we'll do is we have built the calendar hierarchy. Similarly, we will also build a fiscal hierarchy. So here we'll take the fiscal year and then the fiscal quarter. Month will be the same. Fiscal month and calendar month is the same. There's no difference between that. Year and quarter differs. Fiscal year and fiscal quarter will be different with calendar year and calendar quarter. So I would request all of you to go on mute if you're not speaking, because there's some noise coming in the background. Okay, thanks. So, so you can see here fiscal hierarchy. Here also we have this same attribute relationship warning. So we haven't optimized the attribute relationship for fiscal hierarchy. So what I'll go do is, here you can see this is the fiscal quarter and fiscal year. So month will roll up to calendar quarter and fiscal quarter. So here what I'll do is, I'll right click on this. I'll go to new attribute relationship and I'll take a fiscal quarter from here. And relationship type, this won't change, so I'll take it as rigid. Okay. And for fiscal quarter, we'll roll up to fiscal year. So I'll right click, go to new attribute relationship, and then I'll take fiscal year. And this will also be rigid. Okay. So this is my optimized attribute relationship. And
Indra,
yeah,
hello.
yeah, tell me.
Yeah, you are changing the relationship. You should change it to flexible, right? Because you are changing as per this. Rigid means it will remain as such, right?
But let's say I'll give you an example. Let's say in January this per month. Let's say January 2005. So
Yeah.
January 2005 falls under quarter 1 2005. Quarter 1 2005 is the parent of January 2005. And for
Okay.
fiscal quarter, I think it is quarter 3. So quarter 3 2005. So will it change? Will January 2005 fall under some other quarter after 2 or 3 months?
Okay.
January 2005 will always fall under quarter 1 2005. Will it fall under quarter 2 2005 or will it fall under quarter 1 2006? It will not change. So that is why it's a rigid relationship. It will always be under that quarter only. That particular month will not fall under any other quarter, or a particular quarter will always be under a particular year. That won't change. It will not go under any other year, a particular quarter. So
So
that is
you mean so you mean to say that the what is the existing one that will not change, that will remain as such.
right. But
Okay.
that this is with respect to your data, whether the
Okay.
underlying data, the data in your table, whether that is
Okay.
likely to change or not. Whether the data in your table is likely
Okay.
to change or not.
Okay. Okay.
So even if, to be honest, from my, so even if you are keeping this as flexible, it is not that it won't work. It will still work, but from an aggregation point of view, from a best practice
Performance.
point of view, you should set it correctly. Wherever it is a flexible relationship, you should set it as flexible, and when it's a rigid, you should set it as rigid.
Okay.
Flexible relationship, I just gave an example. I think one of the students is asking for an example. I just gave an example. Flexible, let's say you have an organization hierarchy, okay, where you have different departments and different teams. So let's say you are working under operations in a particular team. Let's say under operations you are working under a particular team under a particular project, and then you have 3 people, 6 people working on that project. So that is your organization hierarchy. You have different departments, and then under departments you have different teams, and under different teams you have different projects, and under each project you have team members who work on those projects. Now let's say that is your hierarchy. Now let's say maybe you are working, you are an employee and you are working on a particular project. So after 2 months or 3 months, your project might change. You might work on a different project. So in that case, the hierarchy will also change. Your parent will change. Currently, your parent is ABC. So you're working on ABC project. After 2 months or 3 months, you're working on XYZ project. So at that time, XYZ will be your parent. So that kind of relationship will be a flexible relationship. Yeah, you can say it is similar to slowly changing dimension. It's a slowly changing dimension, but here when we are talking about rigid and flexible, it is about the relationship between child and parent, whether it is likely to change or whether it is not likely to change. If it is not likely to change, then it's a rigid relationship. If it's likely to change, then it's a flexible relationship. So you can see here that for fiscal quarter we are getting the same error which we were getting earlier for calendar quarter. So what we will do is we have to create composite key columns, but before that let me set the description for fiscal year and fiscal quarter. So here we had set for calendar quarter and calendar year. So the same expression we'll use, only instead of calendar we will use fiscal. So this will be, instead of CY, it will be FY. And for year also we will do the same thing. Okay. So I go to the date dimension, and for fiscal year I press F4, and here in my name column I select fiscal year desk. Okay, and for fiscal quarter in my name column, I select fiscal quarter desk. Okay. Now if I process, will it work? It will still not work because I haven't changed it to composite key column yet. So the same issue is still there. So I'll have to change this fiscal quarter to composite key column. So I'll go to properties, and here with fiscal quarter I'll have to take fiscal year as well. So, and the order would be fiscal year and then fiscal quarter. So the combination of quarter and year will give me a unique value for fiscal quarter. Okay. And now if I process, it is succeeded. So now if I go to my browser, I have the calendar hierarchy earlier. So this is my calendar hierarchy, and if I go here, I go to the fiscal hierarchy, you'll see that FY 2006, this is quarter 1 of fiscal year 2006, and it starts from July. So July, August, September quarter 1, October, November, December is quarter 2, January, February, March of 2006 is quarter 3. Here you can see July 2005 is under fiscal year 2006, and April, May, June. So from July to next year June, that is the fiscal year. So you might need to, because every organization has their own fiscal year. So when you're building hierarchies, you might need to create fiscal hierarchies. You might need to build fiscal hierarchies because they would like to view their data with respect to the fiscal year instead of the calendar year. Okay. So this was one more thing I need to mention here, that dim date is a very important dimension because there are many calculations and many features in SSAS which works on the dim date. Like for example, in SSAs there's something called time intelligence. So when you create, so there are some MDX functions which are used for time intelligence, like parallel period, periods to date, YTD, MD, QTD. So those kinds of time intelligence functions, opening period, closing period, they refer to the dimension of type time. So, which is your dimension of type time? Your dim date is your dimension with type time. So when you right click on this and you go to properties, you see there's a property called type, that is the dimension type. So by default it is set to regular. So for any other dimension, if you don't set this type, it is not of much consequence. But since the MDX functions and the time intelligence functions and the time intelligence calculations, they refer to the time dimension. That is why for dim date, it is important that you set this to type time. Okay, so SSAS will know that this is your time dimension, and whenever it does any time intelligence calculation or any those kind of calculations, it will refer to this dimension. Okay. Uh, Also, there are in SSAS, I will show you later when we build the cube, you can build semi-additive measures. Okay, you can build additive, there are three types of measures in data warehouse: additive measures, semi-additive measures, and non-additive measures. Additive measures are the most common, which are additive across all dimensions. Semi-additive measures are a little bit confusing because they are not additive across the date dimension or across some dimensions, but they are additive across other dimensions. And then there are non-additive measures which are not additive across any dimension. So when you build semi-additive measures in the cube, then it will refer to this dimension of type time and it will work accordingly. It will not add an aggregate because it's a semi-additive measure. So I'll discuss that later when we build that kind of a measure in the cube. But that is why it is important to set this dimension with a type time. Also, it is better if you set each of these attributes as well. Then from the performance point of view, it is better. For example, for calendar quarter, you can, sorry, one second. For calendar quarter, you can set the type as date, calendar, quarters. For calendar year, this is just from the performance point of view. It helps SSAS when you provide these information. Years. for month, months, date, days for fiscal quarter. Under date you have calendar and you have fiscal. So you go to fiscal. This is fiscal quarters. And for fiscal year, this should be fiscal years. Okay. So this is how you can refer the time dimension and its attributes time. So that will help you in the time intelligence and time related calculations.
Hello, Insua. Is it mandatory to declare them as the kind of dimensions we are using every time?
For each attribute, it is not mandatory, but for the dimension type, you need to set it as type time, because otherwise some of the SSAS features, they won't function properly because they refer to the dimension with type time. Built-in types, yes. Yes, they are built-in tied. In SS engine, there are some types already defined. So ideally, from there up, when you're defining each dimension, even people go and define for each dimension, they define the type. But it is not mandatory for every dimension to define the type. But for the date dimension, you should define its type, because as I said, some features might get affected due to it if you do not define it as time. So for date dimension it is required, for the others it is not required. You can leave it as type regular. Okay. So now the date dimension that I created it from a dim date table. So, okay, so almost 99% of the time, every organization has their own date dimension, and you will be asked to use that date dimension table in your SSAS solution. Okay, so every organization has their date dimension table in their data warehouse. But let's say I'll just show you another option by which you can create a date dimension even if you don't have a date dimension table. So on the fly, it will create that table and it will create that dimension. So I'll show you just a way how you can do it. But almost every organization has their own date dimension table. So you can go to new dimension. So here you can generate a timetable in the data source. You can choose this option. Click next. Now here you can define your first calendar day and last calendar day. So first calendar day I'll take, let's say, January 1, 2005, and last calendar day maybe December 31st, 2020. Okay. So first day of the week is Sunday, and what time periods I want in my hierarchy. I want year, I want half year, I want quarter, I want month, I want week, and I want date. Okay, language, English. Click on next. So what kind of calendars I require? So one is a regular calendar, and I'll also take a fiscal calendar. So when does the fiscal calendar start? So it starts on, let's say, I'll say 1st of September. And the fiscal calendar naming convention is calendar year name plus 1. So this is my time dimension. These are the attributes. These are the hierarchies. I'll click on generate schema now. So this will generate the table. Welcome to the schema generation wizard. So this will build the table as well in my data source. Of course, I need the rights. If I don't have the rights to create a table in my data source, it won't allow me. So it says create a new data source view. So do I want to create this table in a new data source view, or I want to use the existing data source view? So I'll use the existing data source view. I won't create a new one. I click on next. So it says, do you want to create primary keys? Do you want to create indexes, enforce referential integrity, preserve data on regeneration? So it is now creating the table, as well as the table in the data source view, as well as it is building your dimension in the SSAS scheme. Okay, generation completed successfully, so it is done. Actually, it has created a table with a name time1, because actually in my previous training session I already created it with it already created a table with the name time. So it has to be unique. So it has created another table with the name time1. Okay, so you can see here that this time1 table is created with all these attributes, and these are the hierarchies which are created. You can see the attribute relationships got created automatically. And if you go to the data source view, in the data source view, you can see this time1 is already created. And if you go to the data source AdventureWorks DW 2012, there also you will see this time1 table. And now if I process this, now I go to the browser, I refresh, reconnect. Now you can see these four hierarchies are created. One is my year, half year, quarter, month, date. So I have the year, then semester, quarter one. Okay, this is my year hierarchy, and you can see here for weeks it has created a separate hierarchy. So this is my calendar year. So there are 53 weeks in 2005, and for these are the days under each week. Okay, so this is another way by which you can create your date dimension. But as I said, most of the organizations have their own date dimension, and you would be asked to use that date dimension to build your date dimension, you would be asked to use that table to build your date dimension, because it's a organization standard. So if every project builds their own date dimension, there will be there won't be a standard, and someone would be using something, and in another project another date dimension table is used. So organization wide there is usually one date dimension table which the entire organization uses. Okay, so this was about date dimension. So now we will create another dimension which is also very common in any data warehouse. That would be the geography dimension. So you will find the date dimension in almost every data warehouse, and also geography dimension is very common because users want to view the data with respect to different geographies, different countries, different cities and states. So they want to view the data that way. So geography dimension is also very common. So I'll create a geography dimension now. So I'll be using an existing table from the data source view, and here I'll select dim geography. So geography key is my surrogate key or my primary key, and say I'll take city, state, province code, country, region code, postal code, the IP address locator. Sale territory key, so this geography dimension is related to the sale territory dimension, but I won't bring in the attributes of sales territory here, so I'm not checking this. So dim geography, I click on finish. So this is my geography dimension.
Indra, there's one question I have.
Yeah.
In the data source view, dim geography is not directly linked to the fact internet cells. It's a snowflake one, which is redirected via the dim product. Can we still
Yeah,
use it to slice and dice the sales
yeah,
data?
you can use either, as I told earlier, either you can bring it as a part of another dimension, or
Yeah.
even if you keep it as separate like we are doing it, I'll show you in the cube. Uh, if you create a snowflake dimension, and even if you don't have a direct relationship with the fact, in the cube there is an
Okay.
option called a referenced relationship. So using a
Okay.
reference relationship, you can set up the relationship between a fact and a dimension which is not directly related to it.
Okay. Great. Great.
Okay. So for that you need to use a reference relationship. So here if I go to my geography dimension, now if you go to the country region country, so you can see for different countries the code is there, like for United States is US, for Australia it is AU, for Canada it is CA. So this is actually a design which is followed by most architects. So usually when you look at the table, there is a code column and there is a name column. So for every value, there is a code. For every attribute, there is a code and there is a name. Like for United States, the code is US and the name is United States. So if I, similarly for, if you go to state province, so for each state province there is a number, but there is a name associated for with each state province. So if I look at this dim geography table, you will see you'll be able to understand it. So this is a standard data warehouse practice where we have two columns. One is a code and one is a name. So why we do this, why we keep a name column and a code column is because uh, we want to use the code as the key column, and we want to use the name as the name column. This helps in performance, as well as this helps with respect to the data quality. Why? Because let's say you have one record where you have US as the code and United States is the name. Then you have another record which has US as the code and United States is the name. But after United States there is a space. So what SSAS will do, they will consider United States and United States with a space, they will consider them as two separate members. But if you keep their key column as US, their key column is the same. So SSAs will consider them as one member. So from the data quality perspective also it helps, and also it helps with respect to performance. So if I go to dim geography, this is the dim geography. So you can see here that for each state, province, New South Wales, there is a code NSW. And for country Australia, there is a code AU. Okay. So this is a standard data warehouse practice. You will find this in many data warehouse tables. So I explained why we use this code and name as two separate columns. Okay, so we'll start building the dim geography, but before that, let's take a 5 minutes break, and then we'll come back and we'll continue with the development of this dimension. Okay. Okay. All right. So let's continue with the rest of the things. All right. So what we'll do right now is, since we notice that for country and for state, we have the code and we have the name. So what we'll do is we'll assign the code as the key column and we'll assign the name as the name column, because code is something which SSAS logically works on, and a name is what is displayed. So for state province code, what we'll do is we'll go to the properties window, and the state province code is the key column. So I'll select the state province name as the name column. Similarly, for country region code, that's the key column. So I'll select English country region name as the name column. Okay, and now I will rename this to state province, and I'll rename this to country. So if I process my dimension now, this process succeeded. Refresh, reconnect. So here I have the cities, I have the countries here, and I have the state provinces here. Okay. So now what I'll do is I'll build a hierarchy. So I'll put country at the top, and then I'll put state province, and then I'll put city, and then I'll put postal code. Okay. So I'll rename this to geography hierarchy. So you can see here that it is giving me this warning sign because I haven't optimized my attribute relationships. So I need to go to the attribute relationships tab. Now this is my geography key, is my primary key that will roll up to postal code. Postal code will roll up to city. Postal code, let me keep it as flexible, and city will roll up to state province. That should be rigid because that won't change. And state province will roll up to country. That will also be a rigid relationship. Okay. Postal codes also, I don't think they will change because I don't think they will. I can keep this as rigid. So it's not that, if it changes, you'll face an issue. It's just to provide SSAs with some metadata which will help it in doing the aggregations. It's not that if you, if you make any mistake in any flexible or rigid relationship, then it will not work. It's not like that. So now I process it. So you can see here we are getting the same duplicate key error, and we are getting it for city Augsburg. So we need to check the data because for this duplicate attribute key error, you need to check the data. Until and unless you view the data, you won't understand why you're getting this error. So I'll check this data. So we are getting the duplicate attribute key for Augsburg. So here I will add where city equal to Augsburg. So the reason why you're getting this error is, you can see here that there are two cities in my table with the name Augsburg, and this city falls under the state province Bayern, and this city falls under the state province Hamburg. So when it creates the hierarchy, where it will put it under it? Will it put it under Bayern or will it put it under Hamburg? So that is why it's giving that error, duplicate attribute key. Okay, so there are two cities with the name Augsburg. One is under Bayern and one is under Hamburg. Okay, so that is why it's giving me this duplicate attribute key error. So in order to fix it, what I'll have to do is I'll have to create a composite key column which will be a combination of city and state province code.
Indra, this is Neela here.
Yeah.
How do you determine the composite key columns? Looking at the database, is there any way to see what is the hierarchy should be? Or we have to go by some kind of document, BRD, TRD document?
No, actually you
That this
have
is the hierarchy. That's how the data is stored.
so you won't be able to understand it beforehand. So while you are developing that time, you'll have to check the data in the tables, and based on that you will decide the composite key. So it won't be beforehand, because see, it is a thing with a multidimensional. This is a concept solely for multidimensional SSAS. If you are using some other OLAP tool, this thing will not come. So probably the business will not let you know that there are two cities with the name Augsburg and you have to create a composite key for it. So you will have to, when you're doing the development, you will have to analyze the data. They will give you data in the tables. So you will have to analyze the data in the tables, and accordingly you will have to build the composite keys.
But that is a shot in the dark. I will not have all the data, all the production data in my development environment.
Yeah, I mean, that is...
I cannot let my code break in production.
See, with Augsburg, like this is at the attribute level. So even if with any other, if you set Augsburg, if you set a composite key of city and state province code, okay, even if there are other cities which have which are under 2 state province or 3 state province code, all the cities will be handled. So it is not for one particular city, it is for the entire column list. So what I mean to say is, so when I set city and state province as the composite key column, so that will work for all the cities.
Okay.
It won't work for one particular city.
So what you are saying is, currently we have a data, that's why it gave us an error, and then we decided upon the composite key.
Right,
but at the time of the development, also we have to make sure we have the data, then go ahead with the development. That's what you are saying.
Right. See,
otherwise we won't be able to code it effectively.
Right. So this duplicate attribute key error only you can figure out when you're doing the development. Beforehand, you won't be able to make it out. Until unless when you're doing the development and when you look at the data, so probably you need proper data in order to do this, and you need proper data whereby you can analyze and find out where you need composite key. If you do not have the proper data, yes, there is a chance that you might not be able to figure out that for this column you require a composite key, because it all depends on the data. If the data is like that, based on that you will develop the composite key. And usually, because this is related to the dimension, this is not fact table data, this is dimension table data, and dimension table data is usually it is of a few thousand rows. I mean maximum maybe 10 in dim geography or in dim date. You will maximum have maybe 10,000 rows, or at the most 90,000 rows. So usually for dimension data, whatever you have in production, you have the same kind of data in dev as well. So dimension data, there is not much difference between production and dev. Yes, fact table data, you will see that in production you might have millions and billions of records. In dimension, maybe you have few thousand of records. So, but in dimension, usually you have the same kind of data in production and dev.
Okay, so this dimension, geography data is maintained using SCD type 1. If there are any changes, they are just overwritten. Right? Because I do not see any duplicate or any tracking of the changes.
Right, right. These tables that you see, these are SCD type 1 only. Okay. If it is an SCD type 2 dimension, then probably what I would have done is, in my data here, in my data source view, for dim geography, if it would have been SCD type 2, because this is type 1. So let's say this is a type 2 dimension, and what I would have done is, if it would have been a type 2 dimension, there would be a flag which would indicate my current record. So here I would have, I'll show you an example. Let me open. Yes. So if it would have been type 2, there must have been a flag which would indicate which is my current record and which is my historical record. So I would put a where condition where, let's say, the flag name is current status, where current status equal to 1. So it will only pull the current record.
Get it. Yeah.
Okay.
Okay. Okay. The latest changes into that dimension, basically.
Right.
Okay. Can you go back to management story? I want to see if there are any indexes or something that will tell us more about this hierarchy, of there are any constraint. If you expand it a bit, let's see, look at the, are there any indexes or keys?
Keys are there, but yeah, clustered index is created on the primary key. So here
only on the primary key?
Yeah. So here there's a primary key which is the geography key, and then there's a foreign key, sales territory key, which relates this geography dimension to the sales territory dimension.
Okay, but nothing to tell us what should be the hierarchy. Okay, get it. So we have to purely go by the data.
Right, right. You have to go by the data.
Okay, thank you.
So this is, I would say, one of the development things which, when you're working as an SSAS developer, you will come across this, and you'll have to figure it out how to create the composite key columns. One of the tasks of the developer, I would say. So, so here you can see that it is asking for Augsburg. There are 2 records. So what I'll do is, I'll go to dim geography, and here I have the city attribute. So for city, I will take a combination of city and state province code. State province code and city. Okay, now when you take a combination like this, you will always have to specify a name column. Because if you specify one column as your key column, that becomes your name column by default. But if you select a combination of 2 columns as your key column, then you would have to specify which will be your name column, what will be displayed. So what I want to display is the city only. So this thing is, so now if I process it, so now you can see that I'm getting a duplicate attribute key. The city error is gone. So the issue with the city attribute is fixed, but now I'm getting this for postal code. Okay, so actually what this kind of thing, this is kind of a trial and error kind of thing, as I said, because you won't be knowing beforehand when you're doing the development and when you're analyzing the data, only then you'll come across this thing. And I would say this is one of the development tasks of an multidimensional SSAS developer, because I have worked on projects where I have used multidimensional SSAS. I have worked on projects where I've used Tabular SSAS. In Tabular SSAS, Microsoft has overcome this thing. So this thing you won't come across in Tabular SSAS. In Tabular SSAS, creating hierarchies is very simple. Just drag, just you right click, add to hierarchy, just add to the columns which you require, and the hierarchy is created. So in tabular it is very simple, but in multidimensional SSAS this thing is there. And while you are developing the multidimensional SSAS, you will have to handle this. I mean, that is one of the, I would say, the developer task in multidimensional SSAS while you are building the hierarchies. So this attribute key is giving you the error 12171. So you can see here that this particular postal code 12171, this falls under the city Berlin, but it falls under two different state province codes, Hessen and Saarland, HENSL. So that is why it is giving this particular error. So what I'll have to do is, for postal code, I'll have to add state province code as a composite key column. So you have the postal code, then add the state province code and postal code. Okay. So I'll select the name column as postal code. So it's kind of, you can say, yes, it's kind of a trial and error kind of a thing with respect to this duplicate attribute key, but I mean, that is how it is, the development in multidimensional SSAS. So again, for another postal code, I'm getting this, this duplicate attribute key. So here you can see for this particular postal code, it is under the same postal code is under two different cities. Okay, for under Richmond and under Port Hammond. Now, last time, if you remember, that postal code was under two different state provinces. So we added the state province in our composite key column, but we did not add the city. So that is why if there are two same postal code in two different cities, it is causing a problem. So here I have to add city as well in my composite key column. So previously I had add state province code, but I'll have to add city as well because two different cities have the same postal code. So state province code, city, and then postal code. And now if I process it, so if I go to my browser and refresh, reconnect, this is my geography hierarchy. I have my countries here, and then I have the state province, and then I have the cities under that state province, and under each state province I have the postal codes. Okay, now if you remember that Augsburg was under two state province. If you look at here now, Germany, Augsburg was under Bern, I think. Here Augsburg was there, and under Hamburg also Augsburg is there. Okay. So this is how you build the hierarchies in multidimensional SSAS. Okay. Now the next thing that I would discuss is these are what you in SSAS, the hierarchies that I have built till now. These are called as user-defined hierarchies. Okay. These are user-defined hierarchies. Now there is another type of hierarchy which you might have heard before. It's called a parent-child hierarchy. So a parent-child hierarchy is a little bit different as compared to a user-defined hierarchy. These are called user-defined hierarchy or a multi-level hierarchy. Now, a parent-child hierarchy is something where the parent and the child both are both have a relationship, both have a relationship on the same column. So if you what I would it is hard to explain without an example, so I'll show you an example, then you'll be able to understand. If in SQL, if you heard of self join, parent-child hierarchy is an example of a self-join where the same table, the same column is being referenced to another value of that same column. So parent-child hierarchy is that kind of an example. It's a self-join, what you say. So I'll show you an example. Here we have that kind of an example. Because Microsoft has created this AdventureWorks database, data warehouse for training purpose only. So it has kept all the different kinds of data which we have in a data warehouse. So if you look at this dim employee, this is an example of a parent-child hierarchy. So if you look at this table, so if you look at this table holds the data for each employee, each and every employee. So this is the employee key. This is your primary key. Okay, this is for each employee. Okay, the parent employee key, this is the supervisor of this employee. Okay, this is the supervisor of this employee, and this will refer to this particular column only. So what I'm saying is, see, employee key 1, this is actually for the employee named Guy Gilbert. Okay, now who is number employee key 18 is Guy Gilbert's supervisor. So who is employee key 18? Employee key 18 is Joe Brown. So Joe Brown is Guy Gilbert's supervisor. Similarly for employee keys 2, that is Kevin Brown, number 7 is the parent employee key, is the supervisor, and who is this number 7? It's David Bradley. So David Bradley is the supervisor of Kevin Brown. So the parent, this is an example of a self-join. So parent employee key refers to the employee key only. Okay. So previously, in previous cases, when we created the hierarchies, the parent and child, let's say United States was under California. California and United States, they were two separate columns. So United States was not referring to United States was not referring to another record in the same table. Here, this parent is referring to another record in the same table. Okay, so this is called a parent-child hierarchy. This is an example of self join. So you can see here this employee key, this is the primary key, parent employee key, this is the foreign key. Okay, and when you when we look into the database in the data source view, if you look at dim employee, you can see this relationship. This is actually the the parent-child relationship, the relationship between employee key and parent employee key.
Indra, this is also an example of a flexible relationship instead of rigid. Is it right? Because the employees
Yeah.
might change the manager and the manager might change their designations.
Right. It is, yes, it will be a flexible relationship because the supervisor or manager can change. So you can see here that the parent employee key from dim employee is referencing the employee key from dim employee only. So that is why this relationship is there. Now, when I build this dim employee dimension, you can see that the parent-child hierarchy will be created. So I click on new, create a new dimension. So I select dim employee. So I'll take first name, last name, title, hire date, birth date, login ID, email address, marital status, phone, gender, vacation hours, department name. Okay. So you can see here what this symbol that you see, that is actually a parent-child hierarchy, the symbol of a parent-child hierarchy. It got created on its own. Why? Because this relationship was there in my data source view. That is why it got created on its own. So if I process it, so if I go to the browser and this is my parent-child hierarchy. So if I look at here, you can see here these are actually the employee keys. So that is why it's not showing the name. So what I'll do is I'll create a named calculation. So edit data source view, and here I will create a new named calculation. What is the name of the column? First name, last name. First name, and I'll put a space, last name. Okay. So in my dim employee, so for employee key, what I'll do is properties. This is my employee key. So I'll select my full name here. Right click and rename this as employee. Here in parent child, there's a property called members with data. So by default it is non-leaf data visible. So you need to make it non-leaf data hidden. Okay. And now you process it. So now if you go to your browser and refresh, reconnect, now you can see here this is your parent-child hierarchy. So you can see you have Ken Sanchez. I think maybe he's the CEO of the company, and then you have these people reporting to Ken Sanchez. Then under David Bradley, you have these people reporting to David Bradley. Okay. So now you might, one thing you might wonder that why is David Bradley showing 2 times? Why is Laura Norman showing 2 times? That is because that is due to the data. Okay. So in this data, you can see here for David Bradley. So select star from dim employee, where first name equal to David and last name equal to Bradley. So why it is showing 2 times is because there are 2 records for David Bradley in this table. One is employee key 7, one is employee key 7 and one is employee key 8. So for these two, it is showing 2 times here. Same with Laura Norman. There are 2 records for this person. So that is why it's showing 2 times. I don't know why the data is...
SCD type 2 table?
Sorry?
Is that a SCD type 2 table?
I think so, but let me check it. See, the problem is here that both have current flag 1. So if one of them would have been 0, then oh no, yes, right. This is an SCD type 2. So here you can see the status equal to current. So what I can do right now is, so in order to handle this, for in the query here, replace table with new named query. Here I can write where status equal to current. So this will only give the latest records, not the historical one. One second. Yes. Where status current. Okay. So if I explore the data now, it should show me only the current records. Okay. Now if I write here new named, here I have to write edit named query is was sorry. Sorry, I made a mistake. So that thing actually got deleted. So I can write first name plus last name as full name from the employee. That is,
Indra,
yeah.
when the source is the query, you cannot create the calculated columns.
No, here see new
Okay.
named calculation is grayed out. So you have to put it in the named query only.
I think the current C should be capital.
I think it shouldn't make difference, but okay, fine. So actually when you create a new named calculation, that actually it is a part of that query only. But if you modify this to a named query, then you cannot add the new named calculation only. You have to edit that query and put it here as like this. Okay. So employee properties. So here now if you go to the browser and fresh reconnect, uh, yeah, that the reason, yeah, that see here now it is like many records have been as I put the condition where status equal to current, many records have been filtered out. But this is actually the correct, the records which are currently here. So under, see, under David Bradley now you don't have anyone reporting, but that is, the current, because I filtered out the records which were the earlier records, only the current records are there. So that is why it's little bit, the data is showing a little bit different as compared to what it was previously. But yes, this is the current records, what we have. So under Kevin Brown, we don't have anyone reporting. Under this person, we have these people. So this is how it is. But now we don't have the duplicate records. So these are the current records. So that is fine. So this is actually the correct hierarchy. Right. So one more thing that I would like to mention here is that here you can see that this parent-child hierarchy, it got created on its own because we did not have to do anything. It just picked up the parent-child relationship and created the hierarchy on its own. So why it picked it up is because this relationship was there in the data source view. If in case if this relationship was not there, then you will see that it won't create this parent-child hierarchy. I'll give you an example. Let me delete this thing, this relationship, okay? So I've removed the parent-child hierarchy. Now I create another dimension. Dim employee. Oh, sorry, I'll give another name. Let's say, no, okay, fine. So I'll pick some columns, first name, last name, title, hire date, birth date, and see, it is dim employee 1, so it will create a new dimension. And see, I've created this new dimension, but the parent-child hierarchy is not created. Why? Because I removed this relationship between employee key and parent employee key. So that is why it did not get created. If I can create it here. So what I'll have to do is I'll right click on this, set attribute usage to parent. And now I have this hierarchy. So so why the parent-child hierarchy got created is it detected that relationship from the data source view and it created it. But in case if, let's say for an example, if that relationship is not in your table or in your data source view, then you can create that relationship in the cube as well. So all you have to do is just right click on that column, go to set attribute usage and select parent. Similarly, you can also select your key column by going here, set attribute usage and select key, if that key column is not created earlier. Okay. So that is what brings us to the end of today's session. Oh, one more thing I would like to mention here is that the performance, when you talk about parent-child hierarchies, the performance of parent-child hierarchies is not that good as compared to user-defined. It's not a very good performing feature of SSAS. So it is not that you should, if you have a parent-child hierarchy and if you have to build it, then you don't have any other option. But it is not something which you should encourage, because it is not a feature which provides very good performance. So it's not a feature of SSAS. There are some features in SSAS which does not give a very good performance, but those features are there. Like in SQL also, in SQL there are some functions which do not perform that well, but those functions are there. Similarly in SSAS there are some features which do not perform that well, but they are there because sometimes your data is like that, you have to use it. You don't have any other option, but you should not encourage using it. That is the point. Okay. So parent-child hierarchy is one such feature which does not perform that well. Parent-child hierarchy, many-to-many relationships, distinct counts, they do not perform that well, but sometimes, you know, your data is like that and you need to use them. So any other questions that you have regarding what we have discussed today? All right, so I'll end today's session, and so I'll upload the videos and send you a mail.
Indra, how many sessions will be there for SSAS and then for SSRS? Hello?
Yeah, actually, I'll have to calculate because we have just started, and
Okay.
at least in SSAS, I think for SSAS, at least 12, 10 to 12 sessions I would require.
Okay, okay.
And then SSAS.
Okay.
Okay.
Can you upload the video as soon as possible?
Yeah, I mean,
Yeah,
I just want to
actually,
add, I mean, I saw this Daniel, normally when Akshay cover that, normally Akshay cover it in 13 classes for SSAS. And I told Indra, I mean, we are not time bound, so, you know, he can take, you know, as much as days he would like to.
Okay.
Right, Indra?
yeah. So,
Little flexible
so
on the time, the time taken for the SSAS.
Okay. So who will be uploading the video? Daniel, you
yeah,
or Indra?
yeah,
Indra is
I
still
will.
Okay.
I will upload the videos. It's just that because you know right after and like I'll have to leave for office, so
Okay, okay.
I return from office only then I can upload it.
Okay.
So I'll leave for office in 30 to 40 minutes from now.
Okay. Okay.
Okay. Okay. All right.
Indra, I actually have an error that I cannot connect. I cannot process. I think my machine doesn't connect to local host for MLS services, but I was able to connect to a named services though. Do you want to
Okay.
remote them? So I cannot process.
Okay, you cannot process. Okay, let me. You can share your screen and then I'll be able to tell.
Okay.
Okay, let me make you the presenter once again.
Okay, thank you.